Hello, Advanced Algebra 2. Welcome to the Concept 26 Notes, Part 2, where we are looking at log functions and their graphs. And in this part, we're going to focus mainly on the functions or equations. So you'll want to go in your notes packet all the way to these examples. We are going to describe the transformation of f represented by g. Remember, an x-axis reflection has the negative at the beginning of the function, and a y-axis reflection has the negative by the input x. Now, we do have some base e functions, so those change up a little bit, but we'll talk about that when we get to it. All right, let's look at number 1. So f of x is the exponential equation 2 raised to the x power. G of x is 2 raised to the x minus 3, and then plus 1 at the end. So we have an h value of positive 3, so that's a shift 3 to the right. And then we have a k value of positive 1, so that's a shift of 1 up. Now looking at number 2, so this is a base e function, e to the negative x. So what has happened there is we have a negative value, we call that an r value, negative 1. And so that would give us a y-axis reflection because all of our x's that were positive are now negative. And then looking at g of x, we also then have a k value of negative 5, so it's down 5. Now that y-axis reflection did occur in f of x. And then the only additional transformation in g of x was that shift down. Looking at number 3, we are back to an exponential with just normal numerical base, so we have 4/10 raised to the x, and then g of x has that negative 2 multiplier. We call that our r value. So the negative, again, is another y-axis reflection. And then since the multiplier is by x, then that becomes a horizontal stretch or shrink. And remember, it's counterintuitive. So it's actually a horizontal shrink by a half since we have that multiplier of 2. Now looking at number 4, we're back to a base e equation. So f of x equals e to the x. G of x equals negative e raised to the x plus 6. So we have an a value, and a value out front that's multiplying. That's negative 1. So that's when we have an x-axis reflection. Our h value is negative 6. So it's going to shift 6 actually to the left. I get confused, but I'll come back and fix that in a minute. Now, number 5, I have f of x equals, now we have a log function, log base 1/2 of x. And then to g of x, we have a 2 multiplier out front, and then base 1/2 of x plus 4. Notice the plus 4 is in a parenthesis, so that's an h value. So dealing with the 2 out front, that is a vertical stretch by 2. And then our h value, it's negative 4, so that is a shift of 4 to the left. If it were a k value, it would be outside the parentheses at the end of the log equation. And then finally, one last log equation. So log base 2 of x, and then it's been shifted. We have negative 3 log base 2 of x. So we have an a value of negative 3. So that is a vertical stretch by 3, and then an x-axis reflection. All right, now let's work the other way, and we'll start with a function and then be told transformations to do, and then write a new function. So let the graph of g, that's our new function, be a reflection in the x-axis followed by a translation 4 units to the right of that graph. So we're starting with the exponential f of x equals 2 to the x. So a reflection in the x-axis would be a negative out front. And then 4 to the right, that means that would be an h value of minus 4 by right in by the x. So our equation would be negative 2 raised to the x minus 4. Remember, you can always go to your graphing calculator, your y equals menu, put that on your y equals menu, and put the original one as well, and press graph. If your window is not the way you'd like it, go across the top buttons on your calculator to zoom and press zoom standard. Now let's look at example 6. So we're letting the graph of g be a translation 2 units up followed by a vertical stretch. of this log function. So f of x equals log base 1/3 of x. So g of x, 2 units up, we're going to add 2 at the end of this log function. Then we're going to do that stretch. So we'll put the whole equation in parentheses and our 2 multiplier out front. And then we're going to distribute that 2. So our final function will be g of x equals 2 log base 1/3 of x plus 4. So that vertical stretch happens to the log and also to our number 2 at the end. All right, example 7. We have a graph G that will be a horizontal stretch by a factor of 3. So we'll have 1/3 as our multiplier, and then a translation 2 units up. So starting with that base e function, e to the negative x, our multiplier will be 1/3. So we become negative 1/3 x, and then our plus 2 at the end of the function. So not up in the exponent. And then finally, we are transforming f of x equals log of x, which remember, that's a common log, so that's base 10. It will be a reflection in the y-axis, so we need to multiply that x by a negative, and I went ahead and put a parentheses around it. Now I need to shift it 4 units to the left, so this is going to get a little strange for a minute. I'm going to open up a new parentheses so that I just add 4 in by the x, and that shifts to the left. And then I'm going to go ahead and just get rid of one set of parentheses by distributing that negative. And as I mentioned in the earlier example, I put this on my graphing calculator and looked at my original function and my new g of x just to make sure that all of those shifts were happening. So remember, you can do that by going to your y equals menu, and then when you're done, pressing graph. Always make sure on your graphing calculator, if you need or mean for it to be a negative, that you use the negative sign. That is down kind of at the bottom of your calculator, and then if you need subtraction, that you use subtraction, which is over in the right-hand column. The calculator makes a distinction between those two. All right, this is just a short little part 2 notes of our concept 26, and this concludes those.